All right, my friends, some more fun with macro markets and quant. We're working in R, we're working in the National Income Project. This is not the intro. This is knee deep into it. We're looking at the top line for the U.S. income statement. Again, that's the U.S. aggregate income statement. Go to the Market Observatory and the National Income Project. You can get more info on that. For my students, we're in your project right now in R, the National Income Project. Mine is called Glass Copy. Yours might be called uh, whatever you have. We're going to look at the attribution. So at this stage, you have your data loaded. You have the rest of this national income revenue annual overview run. You have your correlations between prices and quantities and all that great stuff. Now we want to ask this question. Suppose revenues go up by 5% in a given year. How much of that was because of P and how much was because of Q? Uh, I'm curious, but it's also really important for business planning. Think about the people inside of the organizations that are in control of the Qs. That's the volume, that's production, that's supply chains. Think about the people in the organization that are in charge of the Ps. That's the pricing team, sales and marketing, and they're trying to assess customer demand curves. These are different parts of the org. These are different use cases. If we want to understand which one is driving revenue so that we can allocate resources, we need a decomposition. So think about what total revenue means. It is mathematically, total revenue is a price times a quantity. So how do I take a multiplication and break it up so I can treat it kind of like additive? The idea here is we're talking about growth. We're not talking about the level. We're talking about the change in total revenues and what fraction of that change was due to the change in P and what fraction of that was due to the change in Q. For that, my friends, we're going to use log proxy. So the percent delta in TR, the percentage change in total revenue. And that's approximately, double squiggle, equal to the change in the log of total revenue. That's a proxy that works pretty well as long as that percentage change is reasonably small. So what is the total revenue? Well, it's PQ. Why do I have these subscripts? Well, the delta is change over time. So the change in the log in period 2, subscript 2, minus the log in period 1, subscript 1. If you remember some of your rules from logs, when you take the subtraction, it's actually like a log of the division. So I group them together. And then if you remember your rules of multiplication division, you can then separate out P2, P1, Q2, Q1, and then you can break those apart. And that's through the laws of logs. It's tough to say, laws of logs. So it's the log of the price ratio plus the log of the quantity ratio. So what we're going to actually do is treat that as a change in the log for P and a change in the log for Q through similar rules that we had just mentioned. So what this allow me to do is say things like, okay, again, it went up by 5%. Let me compute the log of the prices and look at how that changed from one year to the next. That'll tell me how many percentage points of that total change in total revenue came from pricing. And then let me compute the log of the quantity in one year to the next and compute that change. That'll tell me how many percentage points of the total change in revenue was due to quantity. So let's see if we can do that. So to do that inside of R, what we want to do first is take our combined PQ level. Now, again, if you're just jumping into if you're just joining us live, let's see here, combined PQ level. You can take a peek. I think it's easiest for us at this learning stage to see it in like Excel type form. It's a wide data format, dates, prices, and quantities. That's the way we would think of it. These are not dollars. These are not, numbers of haircuts or pens or whatever. These are index values. You can go to the metadata and check out what those mean. So what we want to do is transform it into a long form. And the reason why we want to transform it into a long form is because I want to start manipulating it, and then I want to summarize it and plot it, and putting it long will help facilitate some of that. So line 580 is pivot longer. What that's going to do is take that wide form and then stack them upon one another. So what are we going to stack? We're going to stack the price and the quantity column that we just saw. We're going to have then a date column, another column called variable, which will either be price or quantity, and another column that we're making called value, which will be the numbers. So let's run that bad boy. And we can take a peek at that. Combine PQ level dot long. It's going to be this one right here. And you can see the way that it looks. Look, it's 47 price and its value. 47 again, quantity and its value. 48 price, 48 quantity. They're stacked. The computer reads that long form much, much better than us humans do. So this is obviously not the only way to do it, but I want you to practice in multiple ways. So then let's actually start generating that decomposition. We'll compute some logs. So I want you to dip into that long form with the Dippler operator. I want you to arrange by date. It should be already, but just in case. I want you to group by variable, price or quantity. So I want to compute the logs only on the variables and the change in the logs only among those prices. See, what I don't want to do, if I didn't group by that variable, I could think about this. Let's go back to that log. It could compute the logs of each, and then it would compute the change from one row to the next. So I'd be wind up computing the change between the 47 quantity from the 47 price. That's not the way our allocation worked, right? Our attribution analysis was the change among the prices through time, the change among the quantities through time. So grouping helps to avoid that issue. Compute the log, log, for the value. We'll call that ln. You could call that whatever you want. And then I want the difference across those. So a couple things that we did here. First thing is we're going to call it NA first, right? The first one, you're not going to have a difference. So we're just going to fill in NA. And then after that, we're going to create the difference among those, diff, D-I-F, F. It's going to look at the log differences and fill them in. So let's run that. Boom. And now when you go back to the combine PQ, delta log long, delta log long. You notice how 1947P has an NA in the last column, and 1947Q has an NA in the last column. Those NAs come from right here. Okay, so then where are those differences coming from? Those differences, where'd you go? Where'd you go? Come on back. There we go. 0.0698. Where's that coming from? That's this log minus that log. About 0.6 gap, 0.069 gap, and then repeats throughout. Okay, so there was a lot in there, and you might be struggling with whether or not you understand the decomposition intuitively, and then struggling with the code. So let's see if we can actually verify it. So what I want to do is actually add together the price log delta, the quantity log delta, which should equal the total change in revenue. So let's verify. What we're going to do is create a new object, wide, just so you can see it, right? Because we think wide like Excel. Dip into the long form. Select only the date, the variable, and that delta log column that we just talked about. Then I want you to pivot it back wider. With the pivot wider, it's a little bit simpler than the pivot long. You're going to find the names. We're going to pull the names from the variable column, so price or quantity, and the values from the delta ln column. Those are the change in the logs. Then what I want you to do is add the two together. We'll call it sum of delta logs. Kind of obvious. Price and quantity, those are the names from that long form, and the way that we add that on is with the mutate. After that, I want you to go back to the very beginning, and when we created the revenue dot delta, that was from the original form of the database, and we grabbed and filtered on all the revenues, and then we grabbed just the delta column. I want you to slap that on. Now, I don't want you to bind because I want to be able to ensure that we're aligning by dates. Don't forget with the deltas, some dates are missing, so I want to align them. So the way we do that is with inner join. You could do outer, etc. By date. And then let's rename it rev delta just so it's clear. And let's peek at the little top of that thing. And we're going to have here, there we go. We got the two pieces. So we got the price, that's from that log quantity. We got the quantity, that's from that log. And then sum of delta logs, that's the addition of those two. So if I took 0.06987, blah, 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 plus minus 0.00694, blah, 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 I get this one right here. That's the attribution analysis. The delta and the log for price plus the delta and the log for quantity should equal to approximately the percent change in revenue. Pretty darn close. Look at these two columns, pretty darn close. So I should have some confidence inside of our decomposition, our attribution analysis. With that ready to go, I can go ahead and plot this out. Now I'm going to plot out from the long, which means I'm not using two geom objects. I'm going to use one geom object called the bar. I'm going to put the dates on the X and then the delta ln, that's the change in the log, on the Y. But I want to have two objects, so I'm going to fill it by what? Well, the variable. Remember, the variable is either the P or the Q. And what kind of object? It's a geom bar. Stat identity is just a way to have them. And I want to stack them. So when you add them up, the total should equal the revenue delta. And the rest of this stuff here is just bells and whistles to make it look pretty and such. And if you run that bad boy, here's what you see. The sum of the bars equals the growth in revenues. And you can verify that, but take a look at the P and the Q. Let me scroll down so you can see that. Zoom out just. I zoomed in so you can see everything in the code, but I want to get the legend in there. So P is red, Q is blue. Take a look at things like COVID. Revenues fell. We saw that from earlier. But how did they fall? Why did they fall? They fell not because there was all this price discounting. The rate of growth in prices was still positive. You can see that with the little bit of red above the zero line there. The reason why it fell is because volumes crashed. And this is for all, across all goods and services. So there might be some that went up, volume, some that went down, but this is the aggregate across them. That's why COVID top line contracted. We can actually do a little attribution analysis with the visual, or we can actually summarize it statistically. So I wanted to create a new object called temp. I removed the prior object called temp. It will overwrite it, but it just best practice. Dip into the long object that we've been playing with, group by variable. Again, just like before, I want to summarize all the stuff just for the P's, then just for the Q's, but they're all stacked long. So how do I ensure it's doing the calculations only on the right ones? Group by. Then I don't want to select every object in there. We have dates. I don't want those, but I do want the delta ln because that's the number. I need the variable to handle the grouping. And then I want to summarize, and we've done this before. With the summary command, the summarize command, what I want to do is avoid typing anything in by hand. I don't want to have to type in here every time delta ln and then delta l. I don't want to have to do that every time because I might change what I'm applying this function to, this bootleg function. So come on, if I break it, I buy it. If I break it, I buy it. There we go. No, not, no, but there we go. Okay, so what we want to do is introduce a list of objects. See in line 669 and introduce some lists. And the FNS is kind of like it's saying it's a function. I want to apply that across all of the items that are numbers is numeric. Because you can think about it, maybe it's the dates that got in there by accident, or maybe there's some NAs. And then what I want to do is apply that to the min, the median, the mean, the standard deviation, skew, kurtosis, quantiles, and max. For each of them, I want to be especially careful. I'm going to make sure NA.RM equals true. Probably it'll be fine, but just in case, if it confronts anything where it's not a number, skip over it, remove it. I want to apply then the round function on top of that. That's just for visual purposes. Numerically, it still has it in there. And the at round just means apply that round function. It's whatever it is, and then you can put the number of decimals. I'll put 2. At the end, we want to clean it up a little bit. It's going to have, by default, the names of the object that it was called, which was delta ln, and it's going to append it to the P, append it to the Q. I don't want that. So I'm going to scrub it out, G-sub, those delta ln's, and just use the column names when you run that. And what you see is that you have sample stats for the attribution analysis, the contributions of price and the contributions of quantity. If you remember, top line revenue growth was about 6%. And what we see here is 0.03 and 0.03. So it's about evenly split. On average, 3 percentage points comes for P and 3 percentage points from Q from the contributions. There's a little bit different in the left tail where you can have big swings in quantity. We saw that in the actual magnitude of in prior videos of the swings in the quantity of volume of goods sold and less than the P. But on the upside, the distributions are about the same. So from a planning perspective, that means that, should I spend all of our energies, bonuses, etc., on my pricing team and none for my supply chain, my org people? Now they're giving you about the same amount, on average, about the same amount for the U.S. economy as a whole, 3 percentage points from each. All right, hope that helps.